So thank you all for this opportunity to say something about performance management, and specifically to give a short introduction to performance management. And I was thinking that the best way to do this actually is to split up the different domains, the different areas of performance management, and to say a little bit about each one of them. So I'm very grateful for this opportunity. My name is Arthur Luimes. I'm a performance consultant. I have more than 30 years of experience in this work. So the agenda is basically about what is performance and why do I need to manage it, why would I need performance management, and also to talk about why performance management is more than just load testing, as you might have heard. Load testing is a very familiar part of performance management, but it's not everything. We'll be talking about the 9 different domains. So we'll be talking about infrastructure related performance aspects, software architecture related performance aspects, but also software development has many performance related aspects. Many things can go wrong in software development when it comes to high performance applications. And then another very interesting topic is configuration management. So you might wonder what configuration management has to do with performance, and we'll go more into that. And then another area is capacity management, to talk about right sizing of your infrastructure, not have too much of your infrastructure, but also not too little. And then specifically one form of monitoring which is not used quite a lot is end-to-end monitoring. We'll just briefly touch on how important that is and what to do to monitor your end user experience well. Then we'll talk about getting to know your application both from the outside in and inside out. We'll call this application profiling. And finally, we'll talk about load testing. And load testing, then all the different types of load tests you can have. And performance troubleshooting in production is then mentioned. And then we'll talk about non-functional requirements and how they can end up in your SLA, and how these different domains and different tests can be used to make sure that all your non-functional requirements are actually fulfilled. So what is performance actually? If you talk to most IT people or IT management people, they usually understand that performance has to do with making things very fast. So basically speeding up your application to become as fast as possible, or at least as fast as needed. But for me, I see it a little bit more broad. I think performance is not just being fast, it's also being stable. So it's not just enough that your application responds in under 1 second, say, but it's also important that this user experience is stable all the time. So it stays 1 second. Whenever the user uses it, whether it's during the night or during the day or 1 month from now, it's always the same experience. And that, of course, makes it predictable. But predictability also has a sort of capacity management kind of meaning, I think. Predictability can also mean that what happens if the number of users would suddenly double? What would happen to your CPU then? So this is also a performance-related aspect. So that you can actually predict from the different conditions that your application might be in, or the different user load that you might have, what happens to your infrastructure. So the speed of the application is very important to determine the user satisfaction. We all know very slow sites. We all know how frustrating that can be. But there's many research on the internet, I won't have time now in this video to go into it, that also shows that actually the profit that the organization makes is directly related to the response time and the stability of their applications. And just to stress it again, stability is at least as important as the speed of your application. So now, why would performance management be more than load testing? Why would you need to do so many things when it comes to performance management? Well, one reason is that load testing alone doesn't really solve all your problems. For instance, if you have a performance problem, you usually need to understand how your application is working internally. And also, if you've load tested it, it doesn't really help the developers directly to prevent creating more performance problems in their code or in the future code that they will be writing. And also, if you just load test in your test environment or in an acceptance environment, it doesn't really alert operations in production for future performance issues in production. So it's like, an analogy is like having a barrel with different staves on it, and then some staves might be higher than others, and the amount of water you can put in this barrel is just basically the amount of, the height of your lowest stave on it. There's a law on this, and I've bent it a little bit, called Liebig's law, and I would say that your performance management is only as good as its scarcest domain. So basically you need to improve the maturity of all your domains in order to become very good at performance management and to make sure your application runs well in production. Now, which domains do we actually have? Let's get started with it. Here is domain number 1. It's infrastructure architecture. Usually with modern applications, you don't have one server or a database and then one web browser. You actually have many, many components on it. In this particular example, you'll see a user who can use either the desktop or a mobile phone. Then there's the internet. Then there's a whole bunch of network components like firewalls and SSL offloaders. There may be multiple web servers and application servers and databases. So if the user then clicks on a button, usually then the traffic goes through web servers, go to the application server, gets some data of one database, and uses that data then to go on to other application servers, which gets it from other databases. And then the data basically travels back in this whole chain then back to the end user. So you can imagine this is not only usually not very beneficiary for the response time, but it also increases the variation in the response time a lot, because each of these components that we've been adding might introduce a small variation in the response time. So you end up with a response time which is highly fluctuating, could be highly fluctuating over time. You'll need to do a lot of things to keep the response time not only low, but also stable. Now, one way to resolve that is to use caches. Now, very often used cache is just a local cache. If you don't need to get your data from the server, you can also get it from a local cache. But if that's not possible because it's dynamic data, then you can also use caches somewhere else in the chain, and then you can see that the application chain is much shorter. So the second domain we'd like to talk about is software development. And unfortunately, what I've been seeing is that the largest number of performance problems I've encountered is that there are performance problems with bad coding. So if there are any developers listening to this, I'm sorry to say this, but we do see that bad coding usually could cause excessive computing, so a lot of CPU utilization or use of memory, which is not needed. Excessive use of backend interactions going to backends when it's actually not needed could be done with a cache, or a backend interaction could be combined. Excessive use of bandwidth, basically just sending too much to the data. Inefficient use of caches. Or memory leaks, which could happen quite a lot. If you have a growing number of objects that cannot be garbage collected, then they can cause a memory leak and eventually instability in your application. Now, we can't really blame developers that they might make these mistakes, because the courses on best practices of writing efficient code are very scarce. Then about the next domain, and that is configuration management. The connection with performance management is actually quite simple. Configuration management is the basis for anything you do, so also for performance management. So if you don't know what you have, then you can't monitor it or fix it or tune it or make it faster. So a very exciting topic, I think, these days is application chain discovery, which basically means that there is software which discovers, you have to run in your organization, it discovers your application chain automatically and then updates that into the configuration information database. And then this information can then be used to connect to incident process or capacity management, which are then also can be used for improved performance. And I just want to mention that it's important that if you do application chain discovery, if you do any configuration management at all, pay special attention to versions. It's not enough just to say, oh, I have this server this application is running on it and it connects to this database, it's very important to know which version of the application is being used, because that will help a lot with troubleshoots in production. And another very important factor would be to add pooling information to the configuration management database. So if your server goes to a backend, then make sure you also add things like max pool sizes and timeouts. The next domain would be capacity management. Capacity management, if you would look it up in Wikipedia, basically tells you it's about right-sizing your architecture. And architecture and infrastructure. And it's basically to make sure you can handle peaks, so a next peak coming up, or there's a trend and more users are using your application through mobile phones, for instance, or if you have any planned event like a marketing activity, or you could have an unplanned event where part of your site goes down, and a lot of users then press F5 in the browser, and this will create a whole lot of extra load. So it's very important to also size it for these unplanned events and actually see if there are any unplanned events in the past that you can learn from. So this is one of the graphs which you might see in capacity management a lot. So there's a particular example is memory consumption going up, and there's a trend through it. And at a certain time you'll reach the max available capacity. And you know that if you don't do anything, then in 2-3 months you'll have a problem, so you better increase the capacity right now. And this is another more advanced graph where there's a combination of both the physical CPU and then the volume of transactions going through your server. So you know that if you sell more, then you need more CPU as well. Now, how do you actually get to a working capacity management process? Now, it always starts with having the right data. Not just data, but having the right data. So really think about it and then log it. And then log it somewhere in a place where it's big enough so that you can have data which contains trend information for at least more than a year, preferably 2 years, so that you can see trends over a longer time. And then the next thing is actually look at your data. Now, even if you wouldn't do anything else, if you wouldn't take any more steps, then if you have the data and you can present it, then it would be very beneficial if you at least say once every week or once every 2 weeks get into a meeting with a number of your IT people, architects and performance specialists to analyze that data and to see what the trends are. If there were any issues related to capacity in the past you could learn from for the coming peaks. So that alone can give you a quite mature capacity management process. Well, if you want to take it a step further, then you can take that data and then trend it or do modeling with it, and then you'll get into the area of capacity planning. And specifically, you can also do what-if scenarios with your data. So what if the number of users would be tripling for my application? What would happen to the response time? So what if I take out a CPU from each of our servers? What would happen then to the response times of the end users? So basically this will give you then the end goal of capacity management, which is to optimize the capacity of your infrastructure. And one particular aspect of monitoring, which I've given its own domain basically, which I think it really deserves its own domain, is end-to-end monitoring. Formally you could say it's part of capacity management because it's just another part of monitoring. But because this is so important to really see what your user is experiencing, I've tried to make it stand out a little bit and given it its own domain. Now, when I talk to companies about what the response time would be of what the user are experiencing, they're usually giving me response times from logs, like say an Apache log or an IIS log. But in general, a response time what you see in these kind of logs are not what the user is actually experiencing. The user is actually experiencing response time which is much more determined by, say, statics, for instance, and the build-up on the screen and parsing of the JavaScript than just a simple log which you see in Apache or IIS. So I highly recommend to learn what the correlation is of the response times, what you see in the log, with what the user is actually experiencing. And one way to do that could be, for instance, to do a video analysis of the screens of the users and see if the user clicks through the different screens, then how that actually relates, the response time that he sees there, how that relates to the response time that you see in log. So you can sort of get a feeling, if I see 2 seconds in my log, then actually the user is experiencing maybe 5 or 6 seconds. So you can do sort of a translation. You can go a step further and to also look at animations and snappy flows. There are all kinds of measures now to measure the user experience when the screen is actually building up and then transitioning. One of them is, for instance, a speed index. And the speed index can also be measured automatically, and it gives you sort of a weighted response time. So it tells you also how much of the screen that the user is actually seeing when the response time is over was actually shown to the user already when the transition was still happening. And this really improves your user experience. Then, of course, this will become extra important if you think about mobile devices, and especially mobile devices over slow mobile networks. So think about how to measure also the response time there. We won't have much time to go into this, but this is a very new and exciting topic, which we can talk about more later. Then, the next domain number 6, is called application profiling. It's basically learning what your application is doing. There's 2 ways, from the outside in and from the inside out. So if you look at it from the outside in, you basically, when we call it network profiling, then basically what you do is you look at the network traffic coming into your server and then going out of your server, and then see if there's a match. So if the HTTP request coming in is only trying to get a phone number, for instance, then it's good that if you see that the database calls which are behind that do not contain the whole phone database. So this is and of course you can look at very many other things with the network traffic analysis, but this is, I think, a good way to see if there are any efficiencies. But that's not usually enough to really tune the application, because you sometimes cannot see where the CPU or memory issues are coming from. And then you also need to look at it from the inside out. So there are all kinds of profiling tools now for Java and for JavaScript on the front end, and for .NET, and then that will tell you, especially if it's used in the combination with the load test, will tell you where heavy CPU or heavy memory usage is coming from. And the main thing is you look there for inefficiencies. First you get to know your application, and then you look for inefficiencies and try to improve it. And this usually can mean that you can improve the performance of your application and the stability of your application a lot without actually changing what the user sees on the screen. Now we'll get to load testing. As I mentioned before, performance management is not just load testing, but load testing is not just one type of test also. So a very commonly used test, for instance, is a peak load test, which basically simulates what your infrastructure is experiencing when there is a peak. But there are many more, like for instance a duration test, where you basically simulate the amount of traffic that you would normally get on your site for a whole month or more, and then look at very fine-grained, is there any instability like a memory leak on it, or are the connections growing or leaking, or are your log files being filled up more fast than you would have expected. So duration tests are pretty much as important as peak load testing. And then you have breakpoint testing, where you basically increase the load until your application breaks. That is also very important in the context of capacity management, to see how much load your application can really handle. But there are many more. There's like session exchange tests, where you can try to see if your application will incorporate session mix-up. So the user data from one session ends up in the user data of another person who clicks at the same time. And then there are fault tolerancy tests, where part of your infrastructure gets switched off, and then see, does the application still survive, and can users still work? And a sort of an example of that would be also a slow backend test, where your backend of the server that you're testing gets slower and slower and slower, and how does that then relate to end user response time, and also when the backend gets normal again, does the application recover by itself, or do you need to restart your server? A variation on that again, it would be a no backend test. You basically switch off during the test, underload the backend, and then see how your application is reacting to it. And then when the backend comes back, then you can expect then also that the application recovers automatically. And if it doesn't, that means that your operations people will have a lot of work when there has been an outage to actually bring your server back up, which is of course undesired. And then many other types of tests you can think of. As soon as you have load, then you can think of many other tests that you can do to actually to test your infrastructure. Now, another important domain, almost the last domain, would be performance troubleshoots, basically troubleshooting the performance in production. And the approach which I would like to have is that you use all of the knowledge that you just gather to actually solve the performance problems in production, and not try to troubleshoot performance problems without knowing really your application. Because when the application is really getting slow or unavailable, then don't assume that you actually have the time to get your no application then. Then the last domain is about SLA management, and specifically about non-functional requirements. Performance and response time is a non-functional requirement, and so you could wonder which non-functional requirements actually have anything to do with performance management. Now, there are a number of models to talk about non-functional requirements. The one I like a lot is the ISO 25010. It tells you about, for instance, time behavior, the response time, but also tells you about resource utilization, capacity of the servers, maturity, and integrity. So there are many different types of non-functional requirements, and most of them have something to do with performance testing, or performance analysis. In this sheet, I've tried to map that. So you here on the left-hand side, you see all the ISO 25010 subcategories, all the different non-functional requirements. And on the top, you'll be able to see all the different analyses that you could do, or the different tests you could do from a performance standpoint. So it basically means if you want to create good quality software and you're very serious about performance management, you'll basically have to do all of these tests to make sure your non-functional requirements are being met. So we've come to the end now. I can imagine if this is new for you, it could be quite baffling. You could be a little dizzy by now, but I think one thing to take home for this, just remember one thing, and that would be that performance management is more than just load testing. Okay, thank you very much for your attention. I'll be happy to talk more to you about other topics in detail. Thank you very much.